Whether you're watching Dr. J rock the cradle right in front of you, or when you're watching some fountains shooting through the air, both Dr. J's flight path and that of the water shooting through the air can be modeled by a quadratic equation. The shape itself is known as a parabola. Parabolas and quadratic equations have many real-world examples. Let's take this example that you're about to see. During the Battle of Gettysburg, Confederate forces were supposed to knock Union cannon off the top of the ridge. After 2 hours of bombardment from 1 o'clock to 3 o'clock on, Union cannon still were not moved. Everything was still in place at the top of the hill, but Pickett's charge had to commence regardless. Over the course of 1 mile, 14,000 rebel forces marched across an open field. By the time it was all said and done, 6,500 of them perished. So does this mean that mathematics had a major impact on the outcome of the Civil War? Union forces held the high ground. They were able to shell the entire time that Pickett's charge was trying to span that mile plus. So even though it may not have contributed directly, it's not the fault of mathematics that the South lost, it still had a very large contributing factor. Projectile motion, parabolas, all of it was related to the way the artillery worked during that Gettysburg campaign. Let's move away from war. Let's start dealing with flight. And not quite the kind of flight that you would think. However, taking a look at the path at which these riders come out, they go up in the air, gravity kicks in, they got to come back down. Oh, by the way, I should probably say, don't do this at home. Because, yeah, they're professionals. Not to mention the fact I'd really hate to get sued because you're like, dude, I saw this amazing thing about parabolas and I had to go home and try it. So please don't do this at home. But watch the path. As this jumper goes through, it comes out to be a parabola. So the next time you're sitting there watching these guys jump through the air, sit there and think, what's the equation of that parabola that they're flying through the air at? Nah, don't do that. Then again, look here. You can see that we have parabolic shapes coming off as the light hits the wall from the light above. Even bananas are in the shape of parabolas. You can go through and create the quadratic function of a banana. I wonder if the minions do this before they eat them. Yeah, I'll have to ask them. Here we have just a satellite array. It will take in the signals from space, bounce it back to the little focus point that's on the top there. This is actually part of the world's largest array that's located in Chile. They send out signals and receive signals. You could have solar farms. Here's an example of a solar farm in a desert. There's a pipe that runs through the middle of that parabolic shape. The sun reflects off that, bounces back, heats up the pipe, creates energy. What an amazing concept. This is by far one of my favorites. When you have a plane that flies overhead, sound comes off in the shape of a cone. When the sound cone hits the ground, it creates a parabola. The intersection of a plane, meaning a flat surface, with the actual cone. Here you can really see the cone coming off of this F-14 as it flies by right above the water. I'm going to let you listen to the sound of a couple of these as they break the barrier. A perfect example of why you see the jets, then you hear them. So what about bridges? This particular one has a nice shape of a parabola. So does this one. When you look at the suspension cables of the Golden Gate Bridge, the shape looks like a parabola. Therefore, it could be modeled with a quadratic equation. Now, I could ask you to come up with the equation, but who's going to do that? Oh, wait a minute. I'm a math teacher. That's exactly what I would want you to do, and here's how it would look. Think you could do it? Seems rather easy enough if you know how to deal with quadratics. However, sometimes in all of our engineering feats, we don't quite get it right. Here's an example. Just sit back and
Then the third longest suspension span that became known as Galloping Gertie as it swayed in the winds sweeping up Puget Sound. 4 months after it was opened, those winds sent the bridge into a rhythmic dance of death. It literally shook itself to pieces. Caught in the middle of the bridge was a Tacoma newspaperman. The bridge twists and sways in its death agony. Since its opening, engineers had studied ways to end its strange vibrations. They claimed to be on the threshold of success, but too late. The reporter, Leonard Coatsworth, manages to fight his way to safety, most of the way on his hands and knees. He abandoned his car with a pet dog inside, the only life lost in the disaster. Giant cables are under stupendous strain as the great roadway of the bridge whips about like some fluttering ribbon. These pictures have been acclaimed as some of the greatest ever filmed. Here it goes.
Well, thank you for taking some time to investigate parabolas with us and the underlying quadratic equation. Hope you enjoyed this little visual. Hopefully it energizes you to try to learn more about quadratics. Hopefully it doesn't make it just plain old paper, pencil, find the vertex, find the axis of symmetry, play connect the dots. Thank you and have a great day.